Hello friends, welcome to engineering tutorial. So we'll continue our discussion related to satellite communication systems. So previously we discussed the basic concepts related to uh, escape velocity and orbital velocity. So in this video we are going to discuss the relationship between these two important parameters, these two important velocities which are given to the satellite while the launch process, the launch sequence. So just a quick recap that the two important velocities, the two important parameters which are required for satellite launch, their escape and orbital velocity. Escape velocity is the minimum vertical velocity which a satellite is given so that it escapes Earth's gravitational field. And once it escapes Earth's gravitational field, a suitable horizontal velocity is given so that it moves around the Earth in a fixed circular orbit, okay, with a certain separation distance between the surface of the Earth and the satellite. So that is called as the orbital velocity. This much we have discussed, and we derived the mathematical expressions for escape velocity, which is this, and also for the orbital velocity. We have already covered this part. Now in this video we will try to establish a relationship between the escape velocity, okay, and the orbital velocity, okay. This, that is the vertical velocity which is required to make the satellite escapes Earth's gravitational field, and the horizontal velocity required to make it move in a fixed circular orbit, okay. So out of these two expressions of escape velocity, one of which is in terms of the universal gravitational constant, mass of the Earth and the radius of the Earth, it is root over of 2gm by r, okay, 2 capital G capital M by capital R, root over. And another one is in terms of the acceleration due to gravity and radius of the Earth, which is root over of 2 small g capital R. So we will be using this one, okay, this okay, this V is equal to root over of 2 gr. So let's say the escape velocity, we pick this mathematical expression which is root over of 2 g capital R. Now here one important thing to consider is that this relationship is valid only for satellites which are orbiting very close to the surface of the Earth, okay, which means that the separation gap is almost negligible. So we picked this escape velocity mathematical expression, and for orbital velocity we again picked this one, so that the parameters which are involved in both of them, they are the same, okay. V0, which is r capital R root over of small g by capital R plus small h, again radius of the orbit capital R, acceleration due to gravity small g, and separation distance or height above the surface of the Earth small h, okay. Now if the satellite is very close to the surface of the Earth as the condition we have specified, then this h will become almost equal to 0. The separation distance, it will be taken almost equal to 0, will approximate it to 0. So when this becomes 0, we will have this mathematical expression. It will reduce to this format, that is the orbital velocity is capital R root over of small g by capital R. So we can write it as orbital velocity is equal to root over of small g capital R, okay. So we have the escape velocity root over of 2 gr, and the orbital velocity for satellites moving close to the surface of the earth with h almost equal to 0, that is equal to root over of gr. So this is only valid for satellites very close to Earth's surface. Okay, this is the condition. Okay, so now if we take a ratio between the escape velocity and the modified orbital velocities for satellites very close to the surface of the Earth, it will be root over of 2g capital R by root over of gr. So root over of gr, it will get cancelled, and we'll have v by v0 is equal to root 2, or escape velocity is equal to root 2 times the orbital velocity. And again, the important condition is that this is only valid for satellites very close to the surface of the Earth. So why this is necessary? Because in certain conditions, in certain situations, we need satellites which are required to move around the Earth for certain monitoring purposes or anything like that. We need them very close to the surface of the Earth. So in that case, this relationship helps in the the specification of the suitable escape velocity and orbital velocity during the launch sequence. So this is a very important relationship between two of the most important parameters which are required for satellite launch, that is the escape velocity and orbital velocity. So we have the escape velocity is equal to root 2 times the orbital velocity, and with the condition that the satellite is very close to the surface of the Earth. Okay, so this is the thing.